Hello and welcome to Sass Bites. This is your weekly bite of Sass during your lunch break. I'm your host, Micah Godbolt. You can follow me down there as well as follow Sass Bites at Sass Bites. Been gone for a couple weeks, was sick, went to DrupalCon, been a whole lot of fun. But I want to come back with you today is actually part of the talk that I gave at DrupalCon this last week, talking about design systems and specifically component-based design systems. It's a talk that we gave myself and a couple of people from Red Hat down in LA for DrupalCon. And I wanted to have an opportunity to give that to my audience as well and actually dive in a little bit deeper than we were able to do in the short session that we had at DrupalCon. So there's a bunch of stuff to get into, but I'm going to walk you through kind of the design system approach and some of the things that make the approach that we use kind of unique and the effects of that. There's a bunch to go through, so I'm just going to go ahead and jump on in. There we go. Oh, let's start on the first slide. So when we came into the project, we were asked to basically take this design, take the site that we'd already built. I was actually there for the building already. To take that and to break it down into something that's going to be a little more modular. The original design that we'd done was anything but modular. It was Bootstrap plus some things, plus some things, plus some things that basically meant if another property, like another sister website of Red Hat, was wanting to use some of our styles, they would pretty much need our entire style sheet, like all 20,000 lines, whatever it is, just to reproduce one single little band of content. So what we wanted to do after the site was launched is get a chance to kind of revisit that and try and create something that was going to be much more modular so that someone could use and just use a small piece of it and really just try and make a better architecture overall. So when we started looking at the content, this is actually live content from the site right now that was built with the original architecture. You can see there's a lot of consistency. I mean, the design was very consistent. It was just the way we implemented it wasn't very consistent. You see, we have real basic layouts. We have like 9.3 layouts. We've got 6.6 layouts. We've got 3-up layouts. We've got 5-up layouts. We have these ideas of cards. We have got black cards and we have white cards. So there's all these different kind of layout concepts and different constructs that get used throughout the entire site. But the way we're approaching it was basically to rebuild them every single time that we had to build a new band. So all the styles are basically attached to that band and dictated how it would look versus abstracting that away. So that was one of the first things we took a look at. Secondly, throughout all these designs, you see we have these really consistent pieces, these consistent components. So here we have like the band headers, which can be 1, 2, or in some cases, which you don't see here, a third line of text that's extremely consistent, like at the top of every single band. We also have the idea of our standard call to action buttons, which are very consistent and look the same across the entire website. We even have like standard text, like this is a list full of links, which is going to be consistent everywhere. It's list items with anchor tags inside of it with specific styles, yet those styles were spread out all over the place. And even the way we approached our media, say like our video embeds and our image embeds and those kind of things, were extremely consistent visually, but not quite so from the code standpoint. Everything was kind of like, all right, we're building this thing. Oh, it has an image. Okay, how am I going to style this image? I'm sure we used some mixins and some extends and whatnot, but it was still, every time we built something, there was more code in the code base, more classes, more overrides, more. So we wanted to break that down. And we knew the first step of that was to create a new set of rules, a new set of tools that we could use to put things together. And each of those tools needed to have rules associated with them. So what we approached was this idea of a set of Roadrunner rules. Roadrunner rules was something that went around the Twitter a couple months ago, of this set of rules that Chuck Jones put out that defines how the Roadrunner universe is supposed to exist. So for the writers and for the animators, they know, for example, that the Roadrunner cannot harm the coyote. He can only say beep beep, and there's no dialogue in the entire thing except for, of course, beep beep. And there's a bunch more there. Go check it out. But these are the rules that the animators and the writers live by. And we wanted to have a similar set of immutable rules that we could use in our project. And we called them our Roadrunner rules. They focus really around 3 different things. I think we have 7 or 8 of them, but these are the main kind of gist of it, is that the layout, which is the idea of these, these constructs that stuff go into, they never affect the components. They never like impose styles upon them. And similarly, a component never does what the background or what the layout's job is, which is to say like the backgrounds, the widths, the gutters, the margins, those kind of things. That separation there is really what is key. And thirdly, that the elements themselves, the items inside, they only have a single class, and all the styles come from that class directly. So I'm going to walk through kind of how some of these rules played out and how we were able to build things with these rules in place. So the single selector approach, OOCSS isn't an anti-pattern. This is definitely something that Ben Frayne would say, and actually did say in his blog post of Atomic CSS Responsive Web Design Anti-Pattern. It's a long title there, but you can go check it out yourself. And he kind of proposed the notion of like, why can't the thing just be the thing? Like, instead of having like a dozen classes on this one component, why can't this component just have a class on it? Why can't this element just have one class on it and we can style that? Ben, who's been on the show before, there's just some really great ideas about moving forward this component-based design system. And I definitely recommend checking them out. So with that in mind, we have this idea of like this standard band title, this red uppercase title that we see all throughout the place. And with the single selector approach, the main thing we want to focus on this idea of single responsibility principle. That there is this one class and it has one responsibility. It does one thing, which is to style this header. So if we look down here, we've got our standard band title, and that is the only class on this H2. And if we look at the styles, we realize we have a single source of truth for this one single class. So that means that this one set of styles goes to this one single class to style this one element on the page. And that's going to be something you can see consistently throughout this design, where everything gets one set of styles from a single class. So the thing can just be the thing, and we can style it that way. We don't have to worry about how a dozen different classes are going to maybe intermix, or styles from a dozen different places are going to affect that single class. There's single responsibility, single source of truth. Put those two together, and you've got a pretty beautiful thing. Secondly, we have the idea of Optin Modifiers. Is that not every component is always going to look the same every single time you put it on the page. Like the idea of the cards, we've got white cards, we've got dark cards, we have cards that are kind of displayed in different ways. We don't want to have these different layout constructs for every single one of those. We want to be able to have modifiers we can apply to that. So here's an example of a card. You can see the RH card layout down at the bottom. It currently has a theme of dark and a justify value of center. Now, those are the two attributes this currently has on it that define the styles on it. So by itself, without those attributes, the card is just it's actually white as default, and it's not centered like you see it is here. But you can add those things on there to get that additional functionality. So we can change from center to justify, and we can see the style of this changes. The same component, all the styles come from the same class. We just have a modifier, an opt-in modifier that allows us to change those styles. In the same way, we can change from dark theme to light theme, and the background changes as well as the stuff inside of it changes. But you see, if we take that class off, both that theme and the justification have zero effect on the content inside of it. This is what I mean by opt-in, is without these styles specifically attached to the original class, these modifiers don't do anything. And in the same respect, if we take that card again and we add something to it, like this align right, you see nothing changes. Now, we have other elements and other components within the system that do accept an align attribute and will make everything align right. But the thing is, this card has not opted into that. So the advantage here is that we know every single permutation of this card. We know every single value that can be applied to it, and we can multiply them out and know the different variations of it. And this makes it very testable because we know all the different circumstances we need to test it on, and much more scalable and maintainable over the time. So having these opt-in modifiers are great because they allow us to do multiple things with the same component. Like our image embed has a bunch of different modifiers for various different things you can do, but it's still the same image embed, and it only has a certain set of modifiers you can apply to it. So opt-in modifier is extremely important. The other thing is we have is opt-in contexts. Now let's take a look at this card again. You see here with the dark theme, the logo or the icon up top is white. Makes sense, white on black. Now what happens when this theme turns to white? The logo turns black. Now you might be saying, hey, you said before that the layouts should not affect the components inside of them. And it's true, they don't, because everything is opt-in as a context. What does that mean? Let's look at this real quick. So we see at the top, this is a single selector. It's just really big, so it's 2 lines. We can see that the link tile icon is white when it's inside of a context of theme dark. And it's dark, it's blackish, when that same thing is inside of a theme of light. So what that means is if we go to this this component, which is the link tile, we'll see the icon in there as one of the elements inside of that that's being styled, and we'll see that it has a couple contexts on it. So this is not something in the card that's mandating colors down into components inside of it. This is something inside of the link tile that's able to subscribe to these other contexts and change their appearance based on those contexts. So opt-in contexts are really powerful, and we see those used throughout all of this system. And it allows us to be able to change our components based on the situation that they are in. And again, all of these contexts are defined specifically and implicitly. So, or explicitly, sorry, so that we know when we go to our link tile, we can actually test every single possible permutation, because we know that there's only 2 themes that it takes, and we know what's going to happen when those 2 themes change. So semantic grid. We all love a good semantic grid, but we also, in this case, we wanted the ability to have a very flexible grid, a grid that we could actually apply in the DOM and not have to have unique classes for every single band that we want to put together, every single combination. So one thing we did not want to do is obviously this, where we've got containers and row wrappers and column wrappers and classes all over the place. Something where if we wanted to change this from a 3-column grid to a 5-column grid, well, we got to go in and move the DOM around and change classes and just basically have to redo the entire DOM structure to do that, and the markup output to do that. So instead, we want to have something like this. What this allows us to do is we don't have any rows, we don't have any column wrappers. All we have is a parent div that has a data attribute of some kind of layout value. And that layout value is then imposed down on those children. Remember, layouts, that's the one thing that they do is impose layouts on their children. So the advantage here is we can set a layout up in our parent, and then anything we put inside of it is going to adhere to that layout. So, these are just components being dropped in. And right now they're image embeds, but you could throw any component in there, and they would all fit in this grid that's specified by the parent. So that means that here's our grid with a gallery of 5. Gallery 5, obviously there's 5 across. But if we want to change that to gallery 6, all you do is change the data attribute. You don't have to touch anything inside of it. You don't have to reorder things or change the DOM or anything like that. Those elements inside, since they're a component that doesn't care about its width or margins or anything, will all just fit into that space. In the same way, we can go gallery 4, we can go gallery 3. So these images that constantly stretch and fit into their space, whatever kind of layout you throw at it, those components will fit into it. Now, one thing I don't get into in this presentation is the idea of using element queries. You're like, well, what if it gets too big and now the image is too large, or the text should be next to it or something? Well, that's what element queries are all about. Being able to use an element query, a little bit of JavaScript in there to switch that context or switch that modifier and change those layouts. So if you want to do this and you're worried about things getting too large and things not fitting right, element queries is the way to go. So on top of that, have these semantic grids that are still controlled like in the DOM. As you put these things together, you can actually set those things in the DOM. We can also enhance it by using Flexbox. Hopefully you can see this in the recording. You cannot see that gray background to save its life. But obviously there's white cards with a gray background. And when a designer sees this, they're quickly going to go, yeah, could you just make those columns all equal height? And you're like, great. All right. Find some JavaScript library, do some hackery and make that happen. And then they're like, yeah, but those buttons, it should all line up at the bottom, right? Kind of like that. And so we'd have more like you would put some padding at the bottom of the div, and then you'd absolute position the button and put it at the bottom and make sure the padding is a bunch of magic numbers, a bunch of crap that to make those things fit. Fortunately, Flexbox fixes all of this. Using Flexbox, you can not only set equal heights for all the columns, but you can also set the flex grow of the centerpiece to grow, whereas the top and the bottom stay the same. So whatever space you have, the whole thing's going to fill up, and you'll automatically get this with Flexbox. Now, IE9, they get this. It ain't that bad. It works. It's fine. They'll use it. They can still click on buttons. They won't have a problem with that. But any modern browser is going to get the full, beautiful, as designer expected experience like this. So Flexbox for us has been this great little add-on tool. We're still using SUSY grids to lay things out, but Flexbox gives us that ability to take it one step further and make these layouts we weren't able to do in the past and we had to rely on JavaScript for. So we can check that JavaScript and just use Flexbox. That's been really good. So the idea of modular design, now that we've got all these layouts, we've got these components, and we've got Optin modifiers and context, we can start piecing these things together and start building these components you saw in those first couple slides. So to do so, we start with this basic construct of a band. The band's got 3 sections: header, content, footer. And these are all sections we can put stuff into. Now you see we already kind of have the forming of some good vertical rhythm here. There's some equal gaps between the header and the content and the footer. So those just automatically come for free with this layout, because that's what layouts do. They do margins and those kind of things. So then the header and the footer, we can drop some content in. We've got like a header band, we can or header component we can drop in the top. Called action component we can drop in the bottom, and we can put content into there and fill that out. In the content section, we can then split this up into there'd be like a 4-4-4, because we're using a 12-column grid concept since we kind of had this bootstrap background. This 4-4-4 kind of layout, so we have 3 equal height columns, equal heights, all that kind of good stuff, all baked in because of Flexbox. So when we drop our cards into there, we can see we can use that light theme card, and the card actually has a couple has built-in margins. So you see we've got this kind of really nice even margins and paddings around everything. But the card even has multiple sections, has a content and a footer section with that nice vertical gutter between it. So now when we start dropping components into our card content section, you can see all those things start laying out. And even the components that go into the card even have that same vertical rhythm to them. So we've got this really nice consistent look with really consistent gutters around everything. And that's all from layouts. We haven't done anything with our components yet. Once we drop those components in, you see they fit in just perfectly, because the components themselves are just going to stretch and expand to fill up whatever space that you give them. So we now have got some image embeds and our default component just for standard text, secondary call to action at the bottom. And interesting to note, the call to action that's black and the red one are actually the same component. They just have a different variation using a modifier. So there's a secondary and a primary call to action, but still same markup. So we can build these things really, really fast. And we can build up pretty much any design that the visual language calls for with this design system. So what that allows us to do is some really rapid prototyping. Now, if you've worked in kind of an old system before kind of the advent of this, designing in the browser and everything being done in Photoshop and, just the old way of doing it, typically the workflow would be requirements turned into wireframes. Those wireframes get sent off to development and designers to basically build 2 things in their isolated little boxes. And then when they're done, they throw it at the themer and basically say, hey, make this Photoshop document or make this markup over here look like the Photoshop document. And usually that's when you pull your hair out, because like, oh, if I'd only had the chance to, change the design just a little bit because of this one thing, or change the markup, oh, just because of this one thing, life would have been so much easier. So our new system of prototyping gives us that ability, where we take our requirements and we move directly into prototyping. Because we have this visual language turned into a design system, we can prototype out everything we need really fast and get feedback on that. Get feedback directly from the stakeholders and QA, and we can do cross-browser testing. We can do all of that stuff before development actually happens, while things are still cheap and not so expensive as getting into PHP and Ruby and those kind of things. So instead of doing this and spending tons of time trying to mock up something, just kind of pulling it out of thin air, we can actually just build pretty much the entire page. We can take those components, we can build piece after piece after piece, and build this page out, build this prototype out using the actual markup, the actual CSS, the actual JavaScript that gets used in the production site. And that's huge, because then we actually get to go through the QA and cross-browser testing. And when the feature actually gets implemented, we also have a place to QA against. So when we see what they built, we can look at what it was supposed to be, and we can say, hey, you missed the mark. You got to fix this. We get to drive development versus development driving the work that we have to do. So huge change because of that. So one of the things that makes this work is the idea of constrained prototypes. Is the idea that we need to build something in our prototypes that's 100% reproducible in our CMS. Now, that's not often the case when you just build a prototype and you toss it to some backend developer. You oftentimes will find that they have to end up changing things and modifying it to get the design that actually needs. And then now we've got this out of sync thing between these prototypes and your actual production code, which means your prototypes are now trashed and gone and completely useless. So what we need to do is we need to make sure when we're building something, we stay within a set of constraints, which means that these components and the layouts need to behave properly in all cases. In other words, we can't just add some markup in, or shove some extra change in, modify this one thing, add a class and slap something else on. We need a system of constraints so that when we build something in our prototype, putting these pieces together, putting these Lego blocks together, that the developers can build that exact same thing out of the exact same components without having to do a bunch of overrides that may or may not work for their system. So how can we do that? Well, let's take this design again, really similar to the one we just built a little bit ago, but with some actual content in it. And what we do on the development side or on the prototype side is we don't do this from scratch. We of course, there's no way we want to copy and paste this code all over the place to build this page. So what we do is we have all these components, and we have a templating system. We're using Swig. You can use Twig. You can use PHP templates. You can use Ruby templates. Whatever you want. Just some templating system that's going to be able to pull these things together. And what we do is we base it all off of some JSON markup. So when we define our band, we can pass in all the values, all the parameters for that band, for our layouts, our themes, our titles and headlines, and then there's this array of content. So inside of that content, we have 3 cards that we then specify the values that go into those card templates. So the themed light, they're justified vertically, and then inside of those cards, we can then put more content. So you can see the first one's got an image, content, and a CTA at the bottom, and the other 2 as well. So when we build something, we don't have control over the content. We don't have control over the markup. Sorry. We can't just change something or reorder something or add a class or add some extra CSS. This is the only way we can build things, and that is our constraint, which means if we can't build what we're trying to build with the system, we need to go back to the system and update that so that it can do what we want. So what we have in the end is we have JSON array. So this JSON array is what gets passed into our templating system that actually builds this entire page out. So I have a huge set of these arrays that build this whole thing out. So we know that if we can represent the design we want with this JSON array being passed into our templates, that the backend developers can do the exact same thing. They can gather the data from the databases and the views and the nodes and wherever they need to get it from, third-party APIs or third-party plugins. They can gather that data together and pass it into our templating system, getting the exact same thing that we can get. So that is pretty huge. Now we can move that one step further, and this is kind of what we're looking at doing right now, is the idea of theme as a service. The idea that we can actually take this theming engine, this theming rendering engine, and take it out of our CMS. So in Drupal, we're not worried about Drupal templates and Drupal theme hooks and Drupal this and Drupal that. What all that we're worried about is pulling together all of that JSON markup and then throwing that at some kind of an API. API that I'm currently working on, and it's actually coming together really well using Happy.js and Node, basically. So what that's going to look like, one of the key parts of that is schemas. is the idea that for every single template that we have, every single layout and every single component, we have a schema that defines what is required and expected from that in that data source. So we have all the different values that can be passed in, as well as what are valid values for that. So like with our image layout, there's only 5 values: bleed, full, left, right, and center. Those are the only values that are possible to be passed into that image layout attribute. And there's also required down at the bottom. Like these are the 2 things that are required anytime you call this method. So the advantage here is we can actually validate our JSON before it gets passed into the system. So we're currently working with Drupal, so that's what this setup is for. And the idea is Drupal would request a schema, and the node server would send the schema back. And then once Drupal's validated the JSON array that needs to pass in to get markup back, passes the validated JSON to node server. The node server basically throws all that at the templates, just exactly like we're doing right now. That's kind of showed you before. And that's returned back to Drupal. And the key here is that there's the same node server, the same API that our style guide uses as well. Because right now we're kind of doing everything internally within the style guide. So we break that off. The style guide ingests that API. Drupal ingests that API. WordPress goes to that API and pulls back. So you have a single set of theme templates and styles and CSS and JavaScript and all these pieces that can be used by various sources. Got a Java app? Sure. Just hit the API, it's going to return markup back to you. So this allows us to create a single set of styles that can be distributed across as many different properties as we need. And the idea is it doesn't have to be the same template every time. You might have some system that needs a different type of template or different type of information to come back. And you can pass that along to the header and it grabs different styles of templates. I mean, kind of the world's your oyster at that point. There's a lot of things that you can do to change how that works. But the idea is to have a templating system that you can use with just a set of data that is constrained enough that you can fill out the properties of each of those layouts and components, pass that into templates, and return the markup that you want. Once you get to that point, you've got a design system that's robust, a design system that is scalable, that is testable, and it's going to take you really far. So that's what we're working on in Red Hat. That's what I'm kind of scheming on every day. If you're curious about it, ping me. I'd love to hear more. If you're doing stuff like this, this is what keeps me up at night and keeps me really excited. So thanks everyone for sticking around and watching this. I know it was a long one. There's a lot to talk about. And as we get further and further into this, there's probably more to talk about as we start. I'm going to try and pull together like a NPM module or something like that you can pull down and do this stuff as well. So hit me up at Michael Godbolt there at Sass Bytes if you got thoughts, questions. If you want to see some of this code, I can get some snapshots over to you. But this is some cool stuff. Theme as a service. We already have data as a service, but let's also start outsourcing our themes as well, so we can have a single API for whatever system. So we can swap out and get a completely brand new system. We still have that theme fully decoupled. Anyway, thanks for sticking around, and we will talk to you next week.